in this problem, we're going to find the current I0 is labeled on the diagram. And if we look at this circuit, we can see that it's has a single source and several resistors. So we're going to use the problem-solving strategy entitled Analyzing Circuits Containing a Single Source and the Series Parallel Interconnection of Resistors. And you remember the goal is to reduce this circuit down to a source and a single resistor. Okay, so if we start working on that, we'll notice, for instance, that the 3K and the 6K resistors are in parallel. Okay, so that parallel combination is 3K times 6K over 3K plus 6K, which is 2 kiloohms. So now let's redraw our circuit with those two resistors combined. Okay, now I0 disappeared when we combine these two resistors because I0 is a current flowing through the 3K, and when we combine those together to get a 2K, I0 no longer appears on this circuit. Okay, now we can combine these two resistors in series, and if we do that, our circuit now reduces to this. We have a 6 kiloohm and a 12 kiloohm. And now these two resistors are in parallel. So we have two resistors in parallel. We can use our product over the sum calculation. It's 4 kiloohms. So now we can reduce our circuit down in accordance with our problem solving strategy to this circuit. Okay. Now, by Ohm's law, if we look, the voltage across that 4K resistor is 9 milliamps times 4K is 36 volts with that polarity. Okay. And so back in this circuit, this voltage is also 36 volts because we just combined the 6K and 12K in parallel to get the 4K. So now we know, for instance, that the current through the 6K resistor, we know that's 6 milliamps. Now we need to back up to this circuit. Okay, so now we know this current 6 milliamps. So that tells us that the voltage across this resistor is 12 volts. Okay, and then as a result, the voltage here in the circuit is 12 volts with that polarity. Now, we need to calculate I0, and if we think about, we go back to Ohm's law. Okay, and if you remember, our setup for voltage and current is this. So if we look at our circuit, okay, we have 12 volts across 3 kiloohms. Okay, and if we calculate, that would give us 4 milliamps. Okay, so on our circuit, there we have 4 milliamps, because here I have, by Ohm's law, we got plus to minus voltage. We got the current entering the plus, leaving the minus. So we put it on the diagram here, and then what this tells us is I0 then is minus 4 milliamps because this I0 is defined in the opposite direction from which the current's flowing. The current